Our final project is on the Groma, which is a surveying tool that the Romans used to lay out perpendicular lines and create rectangular plots of land. A lot of what we know about the Groma is thanks to the work of Dr. Matteo della Corte in 1920. He was an archaeologist who excavated a Groma and reconstructed it, allowing us to know the dimensions today. The term Groma refers to the wooden cross that is created by attaching four arms, each 1.5 feet in length, at 90-degree angles, each with a plumb line with a mass hanging down vertically. To use the Groma, a person would first place the Groma into the ground and then direct a second person who is farther away to move slightly left or slightly right until their stake lined up with the two strings of the Groma. Then they would give them the thumbs up to place the stake down and mark the first datum point. This process would be repeated for the other axis to create datum points at 90-degree angles. And this process is not too dissimilar to the process used by a total station today, which is the device that's used for construction or archaeology, consisting of a laser pointed at a prism on a stick. Della Corte details that the Groma would have been made out of wood and bronze, which was cast through the process of lost wax casting, where wax is sculpted to create a one-to-one replica of the object you're trying to make. The wax is cast in plaster, then heated to allow the wax to drip out, and then bronze is poured in to create a sculpture of the shape that we desire. The bronze would be pretty sturdy, so that even if the wood is destroyed, the bronze pieces could still be recovered to create a new Groma. Unfortunately, the PRL wasn't open for casting during this time in the quarter, so for all the bronze pieces, we instead 3D modeled and 3D printed them. As for the wood pieces, we did some research on what sort of tools the Romans would have in order to do woodworking, and used our own tools available such as drills, saws, and sanders to recreate the wooden pieces. For our Groma, we 3D printed the ferramentum, which is driven into the ground, and then we have a hole which is 1.5 inches in diameter to avoid any bending from the cantilever force. We also have a 3D printed adapter, which would have been made out of bronze, and this allows the rostra to spin freely. And at the top here we have a pin of smaller diameter, which allows the rostra to be lighter. Attached to the rostra is a 3D printed bracket, which keeps the arms at 90 degrees. And then on the arms we use little nuts to keep the string from falling through the hole. And attached to each of the arms we have these 3D printed masses, and this keeps the line straight when there's wind. And this is our Groma. To test the accuracy of our Groma, we marked datum points in both directions and measured the lengths of the legs from the datum points. Looking at this expected right triangle, we calculated an error of about 4.4% in the length of the hypotenuse and an error of about 5.8% in our expected angle. However, this might be due to measurement error, as the ground that we were working on had a slight incline that our tape measure might not have accounted for. The Groma was generally pretty good at making rectangular plots. When we moved the Groma to points A and B that we had previously created and tried to mark new datum points, C and C prime, we were about 3 inches off, or about 0.5% of error. Overall, we really enjoyed researching and reconstructing the Groma and learning more about how the Romans did something that we take for granted today. Thanks for watching!